This is question number 10 from exercise 3.3. The question is, find the number of four-digit numbers that can be formed using the digits 1, 2, 4, 5, 6, 8. The conditions are, the first is digits can be repeated, and the second is digits cannot be repeated. So students, we have already solved such question. You know that a four-digit number is always in the form this way. It will be in this form. So this is how a four-digit number is. In a four-digit number, you have units place, then you have tens place, you have tens place, then you have hundreds place, and the thousands place. Now, in the first case, when the digits cannot be repeated, see, you need to use these digits at these four places. Now, how are you going to do it? See, the digits cannot be digits can be repeated. The first case is digits can be repeated. What do you think it will be? See, as I always tell you that whenever you are solving any such question, you have to think that you are performing the operation. You have to think that you are literally performing the operation. So performance of operation. Performance of operation. Okay, so think from the point of view of performing the operation. So what do you have to do? In order you get the four-digit number, you have to fill this place. Okay, you have to fill this place, this place, this place, this place. And see, when you are filling these places, you will use the word and. You have to fill a number at units place, and you have to fill a number at tens place, and at hundreds place, and at thousands place. So when you will have done these four operations, you will have got the four-digit number, and that number total, how many such numbers are possible, you can answer. So the performance, you have to perform the operation. What? You have to fill a number here. So when you come for filling a number here, in how many ways can you fill the units place number? You can do that in 6 ways. You see this? You can fill this units place in 6 ways. In 6 ways. Because there are 6 options for units place. Any of these 6 number can come here. You can fill any of these 6 numbers. Now you have to fill the tens place. You can fill the tens place again in 6 ways. Why? Because the repetition of digits is allowed. You can have the digits given here can be repeated. Say, for example, in the first case, what did you say? You said that you have 6 ways of filling the units place. So now, students, see, you have 6 ways, but you are going to fill this by any one of the 6 digits. So say you write here 5. Now, once you have written 5, and since the digits can be repeated, you can still have 5 here. You wrote 5. See, from these 6 digits, you chose to write 5 here. That doesn't mean that you cannot write 5 here. You can still write 5 here. So the digits can be repeated. The digits can be repeated. So you can have a number like 5555. So that is 5,555. This number is also possible. Yes, you can have a number 6,555. See, 5 are repeated. So I have here the units place can be filled in 6 ways. The tens place can be filled in 6 ways. The hundreds place can also be filled in 6 ways. Yes, because the digits can be repeated, and this can also be filled in 6 ways. So when the digits can be repeated, using these 6 digits, how many numbers can I form? See, how many numbers of 4 digits can be formed? So the total number of ways that these all can be done one after the other is 6 into 6 into 6 into 6. That is equal to 1296, because it is 36 square. Square of 36 is 1296. So 1296 such numbers are possible. 1296 such numbers are possible. Now then I go for the next one. See here, this was the first one, when the digits can be repeated. When the digits can be repeated. Now I go for the second one, and the second one is when the digits cannot be repeated. So I can fill the units place in 6 ways. But since the repetition of digit is not allowed, when I will select any one of these 6 digits as the units place, for tens place, I'm left with only 5 digits. So this can be done in 5 ways. This can be done in 4 ways, and this can be done in 3 ways. So all possible numbers of 4-digit number is, it is 3 into 4 into 5 into 6, that is equal to 12 into 30, 360 such numbers can be formed. So here I have just multiplied, you have to write it properly. So you know how to write the answer that you will do. And if it is an MCQ type of question, that is for JEE Mains or MST CET, in that you don't have to write, you just have to write the answer. So for that it is enough. Okay, now students, here I would like to say something. Remember that in all such problems of digits, make a point here that in all such problems of digits, when the repetition of digit is not there, when the digits are not repeated, you can apply permutation. When the digits are not repeated, you can apply the permutation. So here what I had, see, I had 6 digits given, and I had to make 4-digit number. I was given 6 digits. I had to make a 4-digit number, and the repetition of digit was not allowed. The repetition of digits were not allowed. So I could have directly applied the permutation concept, that is 6p4. 6p4. And what is 6p4 equals to? You have to start from 6 into 5 into 4 into 3. 6 into 5 into 4 into 3. 6p4, and that is equal to 360. Okay, 360. So I will make a note here, and I want you to write that note, and that note you will remember. Whenever such question you come across, you will apply the note. So the note that we write here goes as follows. See, the note is in problems where we are given n digits, in problems where we are given n digits and we are asked to form a number containing r digits. We are asked to form a number containing r digits and the digits are not repeated, then we can apply permutation concept. Right. That is answer equals to NPR. What is answer? NPR. N digits are given and you have to make a number using R digits. Tell me, students, are you following this idea? Have you all understood?
Yes, sir.
Clear to you all? Good. Very good. Students, so here, we will make we will add something to this. So here what I said that in problems where we are given n digits, so we would write here that, see, as such, even if that was not written, when the question would arise, we would have taken care. Okay, what I was saying is, if you have in these n digits, you have a 0 digit, then you cannot directly apply. So here I will write in problems where we are given n digits, n non-zero digits. You may write here non-zero digits. We are given n non-zero digits. That is, all the digits given are non-zero digits. We are given n non-zero digits and we are asked to form a number containing r digits. Definitely we cannot apply, see, this goes without saying, even if it is not written here, it goes without saying that in the given digit, suppose if I am given here digit 0 here, if I am given 0, then definitely I cannot apply directly. Suppose I was not given 8 and I was given 0. So I have here 6 digits, 1, 2, 3, 4, 5, 6, and I have to make a 4-digit number. Can I apply 6P4? Definitely not. Definitely not. Because see, when you are applying 6P4, what are you saying is you are saying that from these 6, you are taking any 4 and arranging. So from these 6, when you are taking any 4 and arranging, there are chances that you go for these 4 and you arrange these 4 in all different ways. But then you know that 0 cannot come at the thousandth place, at this place. If 0 comes at thousandth place, then it is no more a 4-digit number. So this idea which I gave you, it is applicable when the number of digits given, they are all non-zero digits. And in case if they are 0 digit, then what you will do? You will first make sure that this is non-zero. Okay. And then you will find out the number of ways it can be done. Once this is done, then for the rest, you can apply the permutation because the repetition of digit is not there. I hope you all followed this. I hope you all followed this. We have a question here, number 13. It says a code word is formed by 2 different English letters followed by 2 non-zero distinct digits. Find the number of such code words. Now in English alphabet, how many letters we have? We have 26 different letters. A, B, C, D, E, F, and so on, X, Y, Z. So we have total 26 English letters. Okay, now in digits, how many digits we have? You know, how many non-zero digits we have? Let's see how many in the number system, how many non-zero digits. So non-zero digits are 1, 2, 3, 4. 1, 2, 3, 4. 5, 6, 7, 8, 9. These are 9 non-zero digits. Now try to get the question here. They're saying a code word is being formed. What is being done? A code word is being formed. See, you are forming a code word. Now in that code word, the initial 2 places are 2 English letters from the alphabet. Now those 2 English letters are followed by 2 non-zero digits. They are followed by 2 non-zero digits. So here, see, what do I have at the first place? This is English letter. This is a letter. Okay. Letter number 1. Then here what you have? You have letter number 2. English letter number 1, English letter number 2. And then what do I have at these 2 places? It is a digit. This is a digit. And here also, this is digit number 1. And at this place also, I have digit number 2. Now students, check this out. This gets you the complete code. You remember always I tell you, whenever you have any such problem to be solved, you should always think from the point of view of performing the operation. You think that you are performing the operation. So the operation, the task, the job which they assign you, the job will be done only when you will have filled this by a letter from the English alphabet, this also by a letter, and these 2 by digits. Okay, so let's go for the first one, the first place. See here, the first letter the first letter can be filled in. We can see this is the performance of the operation. We are performing the operation. In how many ways can I fill this place where I have the first English letter from the English alphabet? I can do this in 26 ways. I can do this in 26 ways. Why? Because there are 26 letters. 26 letters. Is the job done? No. Now I'll go for this. In how many ways can I go for the second letter? The second letter I can go in 25 ways. Why that? Because they have clearly said two different English letters. You see this? They have very much clearly specified that the English letters you are using, they need to be different, two different English letters. Then here what you have, now you go for the digit number 1. It is being clearly said that these letters are followed by non-zero distinct digits. These letters are followed by two non-zero distinct digits. Now you know students that as such there are 10 digits, but in those 10 digits you have 0 as the 0 digit. So here you have non-zero digits 9. So you can have the first digit selected in 9 ways. You can have here in 9 ways. And the second one you can select in 8 ways. Once again, it has clearly stated that two non-zero distinct digits. So this is 8 ways. Now you understand students that while performing the operation, we were coming across the word and. We had to do this job and this job and this job and this job. So the first one, that is selection of the first English letter, can be done in 26 ways, and the second one in 25 ways, and the digit number 1 in 9 ways, and the digit number 2 in 8 ways. So the total number of ways I can do this is 26 multiplied to 25 multiplied to 9 into 8. So, this 25 into 8 is 200. I just have to get 26 into 9. So 9 6 are 54, 5, 9 2 are 18, and this is 23. So I got 234 into 200. So that is 46800. So these many code words I can form. I can form these many code words as per the given instruction. As per the given instruction. Now I go for the second part of the question. The second part of the question, they say, okay, so the next part of this question, it says, find number of such code words that end with an even digit. So the code word that you formed, here there was no condition. There was no condition. It could have ended in any way, It could have ended with an even number or an odd number, hardly matters. It could have ended anyway. But the next one that they are saying is it has to end with an even digit. So you have total 9 digits, 9 non-zero digits, of which how many are even digits? You can check 1, 2, 3, and 4 even digits. So there are 4 ways by which we can have the ending digit, the last digit. And since the digits to be selected are distinct digits, remember students, they are distinct digits, the repetition of digit is not allowed. Now, out of these 4, any one you have already written here. So you are left with 3 even digits, and along with these 5 odd digits, 3 plus 5, 8. So in total, you are left with 8 digits, and you can have any one of those 8 digits here. So 8 ways you can have the second last digit, that is out of the 2 digits, the first digit here, 8 ways. Now, so far as the English letters are concerned, English letters from the alphabet, it is 26 and 25 without any change. So how will you write the final answer? Exactly the way I said. Exactly the way I said. And I think you are smart enough to write these answers. So the final answer here you will get is, the final answer is 26 into 25 into 8 into 4. I'll go for 25 into, I'll go for 25 into 4, 25 or 25 into 8 and 26 into 4. 26 into 4 is 104 and this is 200. So I got here 20800. These many such codes are possible. Very interesting question, students. Find the number of ways, question number 14. Find the number of ways in which 5 letters can be posted in 3 post boxes. If any number of letters can be posted in a post box. So here I have 3 post boxes. Okay, normally the post boxes are red in color. Okay, so I have 3 post boxes. This is PO box, post box PB1, PB2, and PB3. Okay, I have 5 letters. They're saying in how many ways can the 5 letters? So I have 5 letters here. So this is letter 1, letter 2, letter 3, letter 4, and letter 5. They're saying in how many different ways can these 5 letters be posted in these 3 post boxes. If any number of letters can go in any post box. What does that mean? Try to understand. It means that different numbers, see, it simply means that what is your aim? Your aim is to mail. Your aim is to mail these letters. Okay. So is it not possible for you to put all the 5 letters in post box number 3? You take all the 5 letters and put it here. So what will happen if you do so? You have 5 letters, you have all 5 letters here. You have all 5 letters here. Okay, and you have 0, 0. So the actual distribution is 0, 0, 5. So this is one way. This is one way. You see this? This is one way. Is it not possible? Is it not possible for us to have 4 here, 1 here, 0 here? Yes, quite possible. So see 0, 1, 4. This is another way, second way. Is it possible? Is it not possible for us to have 3, 1, 1? Yes, 1 letter, and 3 letter, 1, 1, 3. This is the third way. So that's what they are saying, that like this, how many different ways of distribution of letters, 5 letters in 3 post boxes are there. Okay, so I want you to pause the video and solve this. Once you have solved, you can come back. So as I have already said, students, that in all such problems, you literally have to think that how is the operation being performed, and you have to think that it is you who is going to perform the operation. So here we got 5 letters in our hand, and we have to post these 5 letters in the given 3 post boxes, and there are no conditions. That is, any number of letters can go in any post box. So here, see, this is how I will begin. This is how I will begin with. So I write here. So I write here the first letter the first letter can be posted in any one of the three post boxes, that is in three different ways. Similarly, the remaining four letters can also be posted, in three post boxes in three different ways, each. Therefore, I'll write here itself. Let me write here. Therefore, the total number of ways of posting 5 letters in three post boxes is 3 into 3 into 3 into 3 into 3, that is 3 raised to 5, 243. You can copy this. Find the number of arranging 11 distinct objects taken 4 at a time so that a specified object always occurs. B, never occurs. Okay, so students, this is interesting question. See, there are 11 distinct objects. So let me write those 11 distinct objects as, I will write them as, say the distinct objects are A, B, C, D, E, F, G, H, I, J, and K. These are 11 objects. Now what they are saying? They're saying find the number of arranging 11 distinct objects taken 4 at a time. So you have to do the arrangement of 11 objects taken 4 at a time. So if there had been no condition, we would have done 11p4 had there been no condition. But here there is a condition. You know what? They are saying that amongst these 11 objects, one object will always occur. Yes, one object will always occur. That is their condition. It means there is one such object which will always be there in the arrangement of 4. Like suppose you select any 4 in the selection of those 4 objects, that particular object is always there. So let us first of all take that object and decide, let that be K. Let that object be K. Means K will always occur. Okay. So suppose I go for ABC. So with ABC, K will come. ABC and K. If I go for BCD, then also with BCD, K will come. BCD and K will definitely come. If I go for ABD, with ABD also K will come. I will complete this problem in the next video, students. Okay.